This video introduces friction. Friction in solids is also called dry friction. Car racing is so exciting, so much of action and slipping and sliding and winning and losing. But while all this action is happening, did friction ever come to your mind? Think about friction within the engine parts when they move, friction in the bearings of the wheel, and most importantly, friction between the wheels and the surface of the road. No matter if billions are spent on the technology of the engine and the aerodynamics of the car, some races in history were lost simply because of bad traction between the wheels and the road. And traction is all about friction. And you see it all around you in all the vehicles while you're walking, cycling, playing things like carom, and every time a ball is rolling and comes to a halt. It's everywhere. So let's get to the basics and understand what is friction. Frictional force or friction is the resistance to the motion of one object moving relative to another object or surface while both are in contact. Frictional force always acts in the direction opposite to the motion of the object. Force of friction. If you push a book on the table, what happens? It moves and then it stops. What if you do it from the other side? Same result. So you are applying force to move the book, but then it stops the moment you remove the force. Ideally, it should keep moving forever, but there must be a force that is opposing this motion that makes it stop. That force is called friction. The force of friction always opposes the applied force. So when I push to the left, then it acted in the right direction so that it could stop the book. And when I push to the right, it acted in the left direction and once again stopped the book. Now the book and the table are made out of certain materials. Now what happens if the material changes? What happens if the weight of the book changes? Factors affecting friction. For this, I will do an interesting set of experiments using one structure that we built, and it can show all the aspects of friction that we will cover in this lesson. And at the end of this lesson, I will also show you how to make a simpler one as a DIY project as well. So I have tied the cap of the sketch pen to a thread, and I have put the thread in the middle of the thick book to lock it in place. The other end of the thread is taken over a pulley and looped to hook up to a small bowl for putting weights in. Now we start adding weights. Note that the book is resting on the surface of the board and there is friction between them. We are going to keep adding weights to see how much force will it take to overcome this friction. That will give us an exact measure of the amount of frictional force that is there between the book and the table. There. That's 700 grams. Since force is mass into acceleration and the mass is in kgs and acceleration due to gravity is 9.8 meters per second, the frictional force in this case was 0.7 kgs into 9.8, that's 6.86 newtons. Note that there are three things to take in consideration here. 1. Force applied by the book owing to its weight. 2. Force required to overcome the static friction. And 3. Friction between the two surfaces. This is also called the coefficient of friction and it's written as mu, and the value is pre-calculated between different materials. For a book and a platform surface like this, the value of mu is 0.43. In our experiment, the frictional force showed as the force being applied by the weights to move this book, and it was 6.86 Newton. But if you didn't have this experiment to actually see how much force was required to move the book, then you could also calculate this frictional force using the formula F is equal to mu into N. So the mu here was 0.43 and the normal force acting on the book is 15.63 Newton. This equals to 6.72 Newtons, and this is very close to the result we got, which was 6.86 Newton. What do you think will happen if I increase the weight of the book? I'll do that by putting a 1 kg weight on it. And now let's see if the frictional forces have changed. Totaling 1.05 kgs. So the frictional force has increased to 1.05 into 9.8, that's 10.29 newtons. That means an increase in weight or normal force between two objects increases friction. Now let's change the material of the board and see if the nature of the material also affects friction. We have three sheets prepared for this. We have a styrofoam sheet, a synthetic flooring carpet, and a thick rubber sheet. Let's start with the rubber sheet by pinning it on the board. The rest of the setup with the book and weights remains the same. On rubber sheet, it took 1 kg to get the book moving. That's a frictional force of 9.8 newtons, and that's much more than 6.8 newtons, which it was when the book was directly on the board. We can see that the styrofoam sheet offers 7.84 newtons of frictional force, less than the rubber sheet but more than the board. Lastly, the carpet offered the least friction, 5.88 Newton. Now I'll add another twist to the experiment. Under the book, I will put a small tray that we made so that the book fits tight inside the tray. And under this tray, I will stick the same materials that the book is going to slide on. You will be surprised to see what happens. Remember that the carpet offered the least friction on the book when we tried earlier. Rubber on rubber. Friction has increased to 16.17 Newton. Styrofoam on styrofoam. Now you can see friction has increased to 11.76 Newton. Carpet on carpet. Now for the surprise and the winner by a huge margin. The friction increased so much that all our weight, that's 2.05 kgs in total, could not get our book to move. So we got our electronic spring balance to see how much force is required to move it. So you can see that it almost took 2.2 kgs to start moving the book, but then once it was moving, it settled down to 1.8 kgs. Remember this fact that it required a higher amount to start moving, because later on in the lesson we will also learn why that happens. Before we move on, let me do a fun test and tilt the platform in a few of these situations. Here's the book sliding on the board. The angle is shown on screen. Sliding on rubber. Sliding with carpet on carpet. As the angle reaches 90 degrees, the effective weight of the book against the platform becomes closer to zero because all the weight is acting downwards and not against the platform. Therefore, the frictional force also becomes close to zero and the book starts slipping easily. A spring balance is a device used for measuring the force acting on an object, and it does that by using a spring. The spring is already checked and marked after hanging different weights from it because it stretches according to the weight hung on it. For this episode I made one, and the DIY for this can be seen on the channel. The link is in the description. You can very easily make it instead of buying it, and this way you can learn exactly how it works also. So we saw how different materials affected friction. Let's look closely at the same materials through our makeshift microscope camera. The surface of the book seems smooth. The board also is almost as smooth. The rubber is less smooth, as you can see. The styrofoam looks slippery and it has large air pockets. The carpet is really rough. It's like a jungle. No wonder it increased the friction so much that we ran out of weights to pull it. All this shows how different materials in contact with each other change the forces of friction acting on the object. And we saw how the increase in weight or the gravitational force on the object also increased the amount of friction that the object faced. This means that the harder the two objects are pressed together, the force of friction will increase. Do you think there are frictional forces acting on a rolling object? Let's use a simple inclined plane. Do you know what an inclined plane is? It's simply a surface kept at an angle. That's all it is. Now we will stick a marker to it. You can do these experiments with pencils too, but I'm using the bigger markers so that you can see them better. Now we'll roll another marker from this reference marker so that the starting position is always the same. Now let's roll it on the marble floor. Now let's see on the cement paver blocks, on the rough ground, on grass, and let's see on sand. See, on every surface it was different. Now what if we cover the marker with glue and roll it in the sand and then dry it in the sun? Now we'll have a marker with texture of sand, which means that we made it rough. Now let's try all of them again. Now with the split screen, you can see the difference between the marker with the sand and the smooth marker. This shows that an object with a smooth surface will face less friction than an object with a rough surface if both are rolling on the same surfaces. We are going to look at three types of friction: static, sliding, and rolling friction. Static friction is the resistance force that keeps an object at rest on another object or surface. Now we know that friction is caused by the nature of the two surfaces in contact with each other, and that's also because of the irregularities on their surface. Even those surfaces which appeared smooth did have a large number of minute irregularities when we saw them very closely. These irregular shapes lock into one another when the objects are pressed into each other by gravity or by any other force. When we try to move any surface, we need to actually do two things. First, we need to apply enough force to overcome this interlocking, and only then we can keep moving it as long as we keep the force applied. This brings us to a new question. What is easier, to move an object from its resting position or to move it when it's already in motion? The answer seems logical. If it's already in motion, it has to be easier to keep it going. And that's true. This means that you need to apply more force to start moving the object, because you need to first break the locking that is caused by the two surfaces. The force required to overcome friction at that instant an object starts moving from rest is a measure of static friction. Once it starts moving, lesser force is required to keep it moving, because the irregularities on the surface do not get a chance to lock into each other as well as they do when the object is at rest. Sliding friction is a resistance force between an object sliding against another object or surface. The force required to keep the object moving with the same speed is a measure of sliding friction. Sliding friction is always slightly less than the static friction. And there you can see that when we pull the book, first the spring balance shows a higher reading of around 500 grams, and then as the book starts moving, it settles down at 400 grams. What will happen if we increase the weight here by 500 grams? It obviously shows a higher reading. Now the reading on the spring balance shows between 500 and 750 grams. Rolling friction is the force resisting the motion when an object rolls on another object or surface. Now let's introduce rolling friction to this same setup. You can see that the force required has reduced to just about 25 grams and the book is still moving. I hope you realize that this is why we move everything on wheels. I showed you those race cars in the beginning of the video. Most of them were doing something that's called drifting. Drifting actually requires not only an understanding on friction, but a complete mastery over it. You may not realize it, but these drivers are masters at controlling friction. So how does a car drift? Firstly, the car ideally needs to be a powerful rear-wheel drive car. The front wheels do the regular job of maintaining traction with the ground. Traction is a positive connection to the ground and therefore means that the friction between the tires and the ground is high. The front wheels of the car remain in the direction of the motion to maintain traction, and that is actually opposite of what is normally done. For example, if the turn is curving to the right, then normally you would turn the steering wheel to the right and go around the bend. But while drifting in the same situation, since the rear of the car will swing out to the left side, you will have to turn the front wheels also to the left side to remain curving along the turn. Otherwise, if you turn the front wheel to the right, then the car will go out of control. And why they do it is not to show off. Drifting is done to maintain a high speed while going around the corners, because after all, they are racing each other. Now that I've told you this, check out the cars in the video once again and notice the front wheels. Before we move on to the DIY project, let's do a short recap of the lesson. Frictional forces of friction. Friction in solids is also called dry friction. Frictional force resists or opposes motion. Frictional force acts in the opposite direction of the motion. Friction requires the two objects to be in contact with each other. Friction is caused by the irregularities on the surfaces of the objects. A spring balance can be used to measure the force of friction. Factors affecting friction. Nature of the surfaces that are in contact with each other. Force with which the two surfaces are pressed together. Therefore, it is also affected by the weight of an object. Types of friction. There is static friction, sliding or kinetic friction, and rolling friction. Measuring friction. Since friction opposes motion, it can be measured as the force required to overcome any of the three types of friction. Here's one look at all of these. For the DIY, I will show you how to make the same kind of setup that I used earlier to show the frictional forces. Since it's difficult to cut plyboard and all, I thought let's try to use something that can be helpful to you any which way, even after once you're done with the project. So for the board, I thought we could use a drawing board. And it's not very expensive and it will do the job perfectly for this project and perhaps many more projects. And it will also remain useful for a long time to come. It's also good because it comes with its clips and we can use them to clip various surfaces to the board. Now for the pulley, we can use the one like we did. This is from a mechanical toy kit. The pulley wheel is much better and later on you'll see why. But if you don't have that, it should not stop you from trying out the experiment anyway. So in that case, you can also use a butterfly clip like this. Or the simplest is to stick two pins on the board and slide the thread over the clip so that it doesn't spoil the board. The pins will help to keep the thread on the clip. Now for adding weight, if you don't have something like this, then you can also make it by cutting a plastic bottle and tie it with threads. Or you can simply use a plastic bag like this. Now you need to find some surfaces to clip on the board to see how the frictional forces get affected. This is how you can clip the surfaces. Make sure they're absolutely tight and there should be no bunching up or folding happening when the book slides. Get an extra packet of clips for added support. The thread needs to be light, but it should be very strong. For tying the book, you can use the same method that I'd used. First tie one end of the thread to the cap of the pen and then leave about 1 meter thread and tie the other end back to the first knot. This way you will end up with a long loop. Keep in mind that you might have to make this loop longer or shorter later depending on how far down the weights are hanging. I also had to make some adjustments. But keep in mind, if you're not using a pulley, Then the string slipping over the clip also adds to the friction. Therefore, the same weights that moved the book earlier will not manage to move it now. So if you have access to a pulley wheel, it will be much better. And you can see that now it shows the same results. Now for changing the materials under the book, you could simply look for bags in various materials and put the book in them. Here I've used a plastic bag. Then I also found a cloth bag. And this is a synthetic bag that is being used in the markets now. That's it. You are ready to do the experiments that I did in the earlier part of the video, so I won't show them again here. Things required for the DIY project: drawing board clips 4 or 8, pulley wheel, butterfly clips, hammer, 2 thumb pins, rubber sheet, a pen cap, thin strong thread, a heavy book, weights and a bowl to keep them, a plastic bag, cloth bag, synthetic bag and any other kind of bags that you can find. So I hope you've enjoyed this lesson on the introduction of friction. The next lesson is also on the topic of friction, but there we will explore how it is evil, but a necessary evil.